morning, everyone. Thank you for coming to our session. This talk will be called Leveraging Pulsar and Flink for Real-Time Vehicle Profile Management. It will be presented by me and Crystal. A brief introduction of myself. So my name is CJ Guo, CEO and co-founder of Stream Native, the company behind Apache Pulsar. We are the original creators of Pulsar. We have been kind of working with Crystal, who is an enterprise architect from one of the Fortune 100 enterprise, and we're going to share kind of some of the high-level best practice. We work together on leveraging Pulsar and Flink together on solving some of the complicated enterprise-wide problem. So that's kind of the context. I will probably hand over to Crystal, let him set the stage first.
Hi, everyone, and thank you for attending this session. So we decided to tackle a very complicated problem to show how these technologies can help find interesting solutions. So we chose fleet management. I have a very slight overview of how does it look like. You can identify mostly 6 building blocks. They are not the only ones, but they are important ones. Vehicle profile, meaning the telemetry that you receive from the vehicle, a wealth of information that the vehicle sends. The driver profile, you want to know what your driver is doing, how is he behaving, what is the driving behavior. Managing the fuel, it's a source of considerable cost for all the fleet management domain. Vehicle maintenance, you want your vehicles to be in top shape so you don't lose money, basically. Inspections, that means know where something is wrong so that you can react immediately. And cost optimization. Cost optimization is something that is not like salt and pepper that you can put at the end. So I put it at the end, and you see later I also put it at the end of the list, but it's actually everywhere. So what about fleet management? What do we have to deal with? Data collection and curation. The data are coming from many different sources. It can be an app that collects inspections, but it can also be a legacy system or a Kafka streams. We need control and workflow. It's a very complex domain. How do things work together? How do we wire them? And how then, on the third column, we get insights and reporting so that we can control the situation. And finally, at the end, AI applications like recommendations and all the good things that it could bring to the domain. So let's talk a little bit in details for this. The timer is not counting. Is it normal? It's good because I still have 30 minutes. Thank you. So for data collection and curation, we have many different data sources, as I said before, but the data are coming into various formats also. How do we deal with that? The vehicle profile, which is not the formal use of the name. Vehicle profile formally means the description of the specific vehicle. I use it here for the sake of simplicity to avoid terms like telemetry, vehicle telemetry. But think about telemetry. So the driver profile, of course. The systems of records. We need to store these things somewhere. We need to be able to use them along the way. And now, on the control and workflow, real-time control. Now, real-time is a bit misunderstood notion. Real-time is not milliseconds, necessarily. In air traffic control, near real-time is 5 seconds is good enough. If it's good enough for air traffic control, it's probably good enough for fleet management, but it can also be an hour. It depends on the use case. So think on real-time as proper timing according to the use case. So we have to control the core business order and workflow. As I said, there's a lot of things. We will see a bit later the details. Approval processes. How does the business control this? We're still in the business layer here. Alerts and inspections. Alerts, there are quite a few. Did somebody steal fuel, for example? Is the driver having a crazy behavior that makes him dangerous? Insights and reporting. So track the inventory, of course. Metrics on the fuel, a very big source of cost, how you can optimize that. Maintenance schedule. This is a particularly tricky subject. We will have a lot to see a bit later. Remember, it's not a complete implementation. It's a high-level idea of the blueprint. Cost tracking. There are many different costs to track and optimize. And performance reports. And now on the AI, let's say BI case, recommendations. How can I do it better? Workflow optimization, vehicle total cost of ownership, suspicious detection. Did the inspection happen in a place where we don't approve? Fuel efficiency recommendation. If the driver does not have a good driving behavior, he probably consumes much more fuel than he should. So all these are very complicated, and it can become a real mess if we don't design it well from the very beginning. So what are the challenges? Again, notice that the cost is at the end, but you should imagine it everywhere. I just put it at the end, as to close with it. But I will mention cost elements in all of these items. So handling large volumes of in-motion data, that is very interesting. We have a lot of data, and the majority of this data are in motion. You all know what in motion means, right? So the thing here is that large volumes means we have to store them efficiently and work with them. In motion means that they are live. It is not really interesting to stop them and start them again. We will see a bit later why and how. We have to balance real-time processing with long-term storage needs. So if you have to store and retrieve your data to put them in the flow, you fatally introduce latency. How we can avoid the cases where it takes too much time for the real-time use cases. Integrated various diverse data sources, as we said before. Do we have a means to easily ingest data and reliably ingest data so that we can use them? Support event-driven architectures. If you want to send an alert, for example, of fuel theft, you have to be able to support it efficiently. Meeting the demands of real-time use cases, again, real-time in the sense that I mentioned before, but also real-time in the collection of the data, real-time in the processing of the data, real-time in the context of the eventual materialized views that we have at the end. So we need to execute real-time events stream processing. Real-time event stream processing, you know it already. It's taking one stream and do things with it and deduce some results. But also complex event processing, combine different streams, do complex reasoning. All these are stateful operations and arrive into a result. Now we come to the a bit tricky part, ensuring data governance and compliance. If you are in Europe and if you deal with many different countries, the legislations are very different, so you need to be able to comply with different constraints. For your data governance, that's a big chapter, we will talk a bit later. You need to get control of the data so that exactly it doesn't become a mess. Then we want to facilitate the analytics and continuous improvement. We want to have very short improvement loops so that we can do better quickly. And of course, the cost management. There are two parts in the cost. Is the cost of implementing the solution. Okay, how much does it cost to use a specific technology to solve this problem? And the other part is how this technology can help me optimize the cost of my operations. Okay? So these are the business requirements. Let's move a bit and see how they transform into, let's say, technical requirements. Connectivity. We want to be able to connect to different data sources. So if we would have already made connectors that we can use, that would be great. We have to be able to recognize different data formats. Apply transformation logic and validation if it's necessary. On the storage part, we want to keep the data in motion as such. So we have to store them, but also keep them in motion at the same time. So deal with streaming data. So we be able to support both queuing and streaming, and be able to store long-term data. I will stop a bit here, and I will speak a bit about the streaming data mesh. It's a concept that you probably know already. It would be interesting to structure our data as data products and make sure that we make them available properly so that we start composing other data products. So this is a fundamental principle in this architecture, in the data organization. We will talk about that a bit later. Process, stream processing, of course, be able to query state or create materialized views, or eventually materialized views of the materialized views. Analyze the data streams as data tables. That is always very, very interesting. So having complex calculations with teams that are very, very good in programming languages provide the facility, for example, of SQL to other teams. And governance, we want to have schema validation because we want to know what to expect from the data products that I mentioned before. So data quality and control, how is the quality of the data that we received in the very beginning? We don't want to get garbage in. We want to have reliable raw material to work with. Data lineage, that is an interesting topic, a very interesting topic in itself. When we are processing, we are executing the business process, and we are doing all these steps, are we able to collect information on every stage? How did the business process perform? So that we can attach this information to the data product that we produce at the end, so that we have a complete view of the quality of the data that we are producing, so that the users can give better results. Security control, are we able to protect the data, to have complete control of whom we give access to the data, to write and read from this data? And last but not least, multi-tenancy. We will talk about that a bit later. We have a lot of data to organize. We need something efficient to do it. Now, we need to choose platforms to do that. I will lead the stage to Sigi, who is going to present the Streamlit platform.
Definitely, I think vehicle profile management, fleet management in general is a very complicated enterprise problem. And I think it's just an example. And I think Crystal did a great job to kind of organize the technical requirements into enterprise that need connectivities. You need to connect segregated data sources together and store those data sources as continuous data streams and potentially materialize them as data tables that you are able to process and query that. And that eventually became reusable data product. And the entire process from connect to store to process, you need certain governance tools to making sure you're able to meet the entire enterprise requirements. So that's eventually became what we have been kind of working on is we get started from Pulsar as an open source project and evolving the Pulsar core towards a multi-protocol multi-tenant and multi-modality like data streaming engine. And recently, we also partnership with Vivorica to bring in Flink engine as a processing engine and querying engine to be able to process data within the same platform. It eventually became one platform that is able to use for building your messaging and streaming workloads. And when we enter the age of the AI, these will become fundamental building blocks for your AI applications. So I'll probably give a quick view in regards to what components that we provide in order to kind of meet what vehicle profile management will look for. So essentially, that will break down into connect, store, and process. That represent kind of three major components that we offer to our customer. The first one is what we call universal connect. The second one is more based on Pulsar. We evolve the Pulsar engine towards a more commercial engine called Pulsar engine. And the last piece is the managed Flink that is powered by Vivorica. So a little bit kind of quick overview about individual components. So people using Kafka, you already know Kafka have a framework called Kafka Connect. And if you're familiar with Pulsar, Pulsar also have a similar framework called Pulsar IO. So we are kind of living in a world that is separated by different frameworks there. The concept of universal connect essentially is to just bring these two frameworks together so then we can embrace the same ecosystem. So you don't need to write duplicate code for Kafka Connect, duplicate code for Pulsar IO. You can just use your favorite API to write the connector, and all these connectors can share the same runtime. You're able to kind of using a consistent and declarative experience to describe how you want to connect the data into your system. That is called universal connect. The second piece is once you solving the connectivity issues, you get data into your Kafka, and essentially over time we have been kind of evolve our engine that was based on Pulsar towards what we call Pulsar engine. Essentially, in short, you can think about it as a Kafka API compatible engine, but it's beyond Kafka protocol. It's actually multi-protocol. What does that really mean is the protocol interoperability between different systems. At the end of the day, I think what brings enterprise value is to have a capability for people to write messaging, using it a messaging queue or using it a stream that you are just writing real-time applications. You shouldn't worry about what is Pulsar, what is Kafka. I just need a stream, need a queue. And the purpose of that is that we should have an engine that is stored one copy of data, and you're able to kind of use a Pulsar protocol or like a Kafka protocol to develop your application. And that is the motivation of Pulsar engine. It's built on Pulsar, but providing Kafka API compatibility and extend that towards supporting multiple protocol. Right now we support Pulsar, Kafka, and MQTT, but at the same time, we are also looking into supporting AMQP to make it more interoperable in the protocol layer. And within the storage, just as what Crystal mentioned, cost optimization should be along every step in large enterprises. And so we offer kind of a balance. You're able to choose between cost optimized and latency optimized based on your kind of requirements there. So that's the core of the system that is serving the ability to storing streaming data or even eventually converting the data into lakehouse table so you are able to process in credit. And the last piece is the process engine that is able to process data in real time and also be able to kind of really unify stream and batch processing, and that is famous Flink. To put all this together, the entire solution should be also a multi-tenant solution, meaning you don't need to spinning up clusters for individual use cases in individual team. You can just put it in a shared multi-tenant environment and have a strong guarantee through like schema, making sure all your data is protected through certain like data contract, and there's an informant's validation that is done at the beginning of where data is coming from. And you should have different security mechanism that is able to protect the data to ensure you meet your company's compliance and security requirement. So it's a very quick overview in regards to how we fit into the solution. But the talk itself is actually about what is a real-world implementation. So I would hand this back to Crystal, let him finish the talk.
Thank you. Thank you, CJ. Okay. So there we are. Now we are going to get our hands dirty. We had the requirements, the business requirements. We translated them into technical requirements. We have a candidate platform. Is it fit for purpose? Let's see. I took the rectangles of the fleet management and arranged them around the same native platform. Okay, now we will go through our items that we had before, our requirements one by one, and we'll see how the platform can handle it. So handling large volumes of in-motion data. I said it before also, we don't want a data mesh. It's better to have a streaming data mesh. So the idea is create the core data products and build on those. So there's a lot of data. If we manage to organize the data in such a way that other teams can pick up the proper data and work, we do not create an application for fleet management. We create a data ecosystem with the proper tools that we can do much more. So how can we do this? We can use, first of all, the multi-tenancy of Pulsar to organize the data. For example, the telemetry data from a vehicle are not the same domain like the maintenance-related data. So some domain-driven design will definitely help in you identifying what. There are interesting uses of event streaming with data in motion. If your data product, which is a topic, implements event streaming, you can have the full history from your topic or read compacted so that you just get the latest version. These are very important tools to give the possibility to your consumers to pick up what they want. Balancing real-time processing with long-term storage needs. It seemed to be a bit contradictory in the past. If you want long-term storage, you have to store them somewhere, we have to load it, and then that penalizes the real-time use cases. In the case of Pulsar, we can store the data in motion once and configure the appropriate retention. So which retention depends on the business needs, and it's easy to configure. Then we have low latency access in Pulsar, but also very efficient, very fast Flink processing. And so our real-time use cases shouldn't have any problem. We have to integrate various diverse data sources. CG mentioned it before, very rich connector ecosystem, Kafka, Pulsar protocols, and other sources. I should mention also the cases, the not rare cases where you do have to do your job yourself because for various reasons. Legacy systems, you want to extract data and create producers and store it themselves. This is also possible. So let's give it a shot. Supporting event-driven architectures. Let's take the inspections and the approved inspection locations as an example. Approved inspections locations are the locations where the inspection should happen. So if we take these streams and we join them, and we do some reasoning, which is stateful, we will talk about that a bit later, we can easily deduce suspicious inspections. Subscribing to that topic give us the possibility to give very quick alerts, for example, in an app. How we can meet the demands of real-time use cases. The vehicle profile can provide us information if we process all this data using event stream processing. on fuel theft alerts. Has the fuel decreased while the vehicle is standing in the same location, for example? And again, as soon as possible, send alerts to an app so somebody can react. Let's go to the more involved things. Some event stream processing. On the left, you see all the information that is coming from the vehicle telemetry. So if we collect it and store it in our data product of telemetry data, we have several options. One of the options is to do event stream processing and deduce eventual part failures. This is actually what we call predictive maintenance. So this information we'll see later how it can be used. We can also deduce a lot of things about the driver and create in real time the vehicle, the profile of the driver. From the driver profile, we can deduce safety alerts. Is he driving in a dangerous way? Or is his way of driving provokes fuel inefficiency? And of course, react accordingly. Now, notice the green parts. The green parts is the Flink operators. When we do the processing, these are the places where you can collect interesting information about the outcome of your process. So this is your business process, but nothing prevents you to collect individual information about the way your process is behaving. And this is something that you could use later to do the lineage. Let's go now into the complex event processing. This is a more involved use case. We have telemetry data, and we pick up the defect troubleshooting codes from this data. In the meantime, we also deduce the part failures, as we did before. We also have an input of maintenance schedules regarding the individual vehicles. If we put that in the proper place and we do complex event processing, we can deduce several things. Here, as an example, I've mentioned the service tasks. A service task is, I have a problem, so I need to do something to maintain the car. It has to go for service. I can deduce maintenance alerts, so that people that are involved know that something has to be done. I can create inspection requests. But it doesn't stop there. Service tasks have to be associated with parts. Do we have the parts? So it's a little bit of more complex event processing. We can keep track of inventory alerts, and we can warn the inventory part that something has to be done, and produce work orders which go to the proper shops for the repairs. Again, in this kind of processing, it's very important to collect intermediate information of how it behaves, because you really want to have dashboards for that. So, data governance and compliance. So let's build streaming data products in Apache Pulsar. Use Flink stream processing capability to collect lineage information, as I mentioned before. We profit from Pulsar's immutable logs and Flink joins to comply to policies like consent manager in GDPR. For example, if you would like to use vehicle telemetry data, you probably need to have the user's consent. An efficient way to deal with this is to perform joins on this. I think we are over already? Okay. Can I have one? The last one? Okay. We were very ambitious. So, what does it all give to developers and to the business? For developers, reusable data streams, simplified operations, focus on applications and innovation, and accelerated productivities. For the business, real-time use cases, time to market, consistent and secure applications, and AI ready. Thank you very much for your attention. I don't know if we have any questions. I don't know if you have any time for the questions. Not really. Yeah.
Yeah, sorry, I have a question on the governance, so that you skipped.
Yeah.
So, well, when we have access to data, it could be quite complicated because of the consent. So it's not simply access, not access. It depends really on the consent based. On the other hand, you have ACL, access control list, for the access control. How do you map this complexity of access management with simple ACL?
Well, can you repeat the question, please?
Yeah, the fact that when you ask for getting access to data product, in that case,
Yes.
Well, you will have to show the consent to define what kind of access do you have. It's on specific teams or even on specific purpose. The same people for two different purposes.
Oh, okay, I see. So when we get into other, well, I think it's a long discussion. We can have it
okay,
outside. It will be too long for that. But happy to respond. Thank you very much.